I've listed on the whiteboard the three temperature scales that are in common use in the United States. These really represent three different ways of stating or options for stating what the temperature is. I like to say that even though you could look at these as maybe three different units, there's maybe more going on here. But recognize that the Fahrenheit scale, which is still in common use in the United States, is not in common use in many other countries. Many other countries have essentially gone metric and use the Celsius scale for stating, temperatures like how warm or cold it is outside instead of Fahrenheit. I still personally think that there's maybe some advantages to using Fahrenheit, and part of that has to do with the fact that if you look at the freezing point, this is referencing the freezing point of water and the boiling point of water in this little table I constructed here at atmospheric pressure, because it would be affected if pressure changes, those numbers. The difference between 32 to 212 is 180 degrees Fahrenheit, and the difference between Celsius 0 to 100 is just 100, right? So that tells you that a change in 1 degree Fahrenheit is not the same as a change in 1 degree Celsius. Really, if I said the temperature increased by 1 degree Celsius, it would increase more than that in Fahrenheit by a factor of 180 over 100, which simplifies to 9 over 5. Going the other way, if I wanted to go from Fahrenheit to Celsius, at some point maybe I'd like to multiply by the reciprocal 5/9, and that's what you see here in this first formula on the key concepts page. So this is really the formula that if you have a temperature in Fahrenheit and you want to calculate what that temperature would be in Celsius, you can just plug into this formula. Of course, if you want to go the other way, you'd maybe have to isolate algebraically T sub F so that you could just plug in for T sub C, the temperature in Celsius. But I wrote it this way because maybe more often than not in the United States, we find ourselves in the position of wanting to go from a commonly stated temperature in Fahrenheit to a more SI kind of basis and convert to Celsius. Now, I also have here the Kelvin unit, because if you ask like, well, what really is the unit of temperature in the SI system? The answer is the Kelvin, and that's what it states down here. And how do you get to that? If you have a temperature in Celsius, you have to add 273.15. And the reason for that is because in Celsius, the absolute zero temperature, which really represents the lowest possible physical temperature, is at minus 273.15. So if you want to have a temperature scale that has that as its 0 point, you need to add 273.15 to it. So that's what you do again to go from Celsius to Kelvin. A subtlety here is that Fahrenheit and Celsius, both of them, have this degree symbol. And I've talked to some different scientists about like, well, why is that? What does it mean? And I'm going to share with you kind of my opinion of that. I think the Kelvin really is the only physical unit of temperature, and that it's kind of, maybe you can make an analogy between like maybe radians versus degree measure of angle. The radian really is the physical measure of an angle, and the degree is just another, maybe you could even say, mathematical contrivance that does the same thing. And I think that's how you can look at temperature, is to say, well, there are different ways of representing temperature, but because the Fahrenheit and Celsius scales are really not zeroed appropriately based on our deeper understanding of what temperature maybe really is, which I haven't, if you ask like, well, so what is that? Can you share that yet? Maybe my answer is no, I'm not going to share that just yet. As we go through this chapter and really maybe even the next couple chapters, I think our understanding will deepen of what temperature really represents. But based on that deeper understanding, it makes more sense that the physical unit should be based on zero corresponding to absolute zero. And since Fahrenheit and Celsius do not have that characteristic, they really are not physical units in that same sense. However, it turns out the SI system does define the Celsius in relation to the Kelvin unit, because there are 100 degrees Celsius, right, between freezing and boiling. There's also 100 Kelvin between freezing and boiling. So it turns out that an incremental change of 1 Kelvin is equal to a change of 1 degree Celsius. So that's why you commonly see scientists, when in a lot of experiments where we're far away from absolute zero, which is common for the environment that we live in as human beings anyways, it may not make sense to use the Kelvin scale. And so it's convenient to at least have the incremental change that represents, one change of either unit or measure be the same for both. And it turns out, I want to talk maybe briefly before I end this video about the basis, the historical basis, and really the definition of these different temperature scales. The historical basis for Fahrenheit, we're going to see that come out a little bit in some of the examples. One could argue that its definition is essentially based on these two numbers, freezing being at 32 degrees Fahrenheit and boiling being at 212 degrees Fahrenheit. But we'll see it kind of has a more interesting story than that when you really go back to like where did it come from, and there's more to it. Celsius, though, really at its very inception was based on the two numbers corresponding to freezing and boiling, although it turned out it didn't exactly start with these two numbers, but it was really, really close. And I think we'll see that in an example as well. But it turns out at some point in the SI system, there was a time period, a pretty long time period, I think. I'm not sure exactly when it started. I know when it ended, though, in 2019, where the Celsius and the Kelvin, both of those scales were actually, their formal definition was based on the triple point of water. And then in 2019, that changed. And now the Kelvin unit, and you could argue maybe by inheritance the Celsius unit, I haven't looked at the exact language lately, but I think it's in there as well. But it is based on an exactly defined physical constant. So they kind of redefined everything relatively recently. So the Kelvin scale is no longer based on the measured triple point of water as it used to be, but is now based on a defined constant, which can then, there's still kind of an experimental aspect to it, because that definition allows us to create kind of a way to measure what really should the Kelvin, like a change of 1 Kelvin actually be, and then that relates to what therefore a change in 1 degree Celsius should also be.